Yeah. Hi everyone. Today we'll be kind of starting with this series of building a project related to deep learning on the site called DeepML. So this is a website where you can kind of practice and develop things related to machine learning and deep learning. So like similar to Lead Code and HackerRank, where you practice problems for data structures and algorithms. DeepML is a very good website where you can kind of practice implementing the mathematical algorithms behind machine learning, or let's say simple things like writing a loss function from scratch, um, training a simple linear regression model or something in NumPy, or even training. Some deep learning models in PyTorch from scratch. So this is a very good website if you want to get some hands-on practice uh, for those kind of problems. And also they have this section of projects where like there are some good options like related to, let's say, deep learning, machine learning, reinforcement learning, some system design, GPU programming, etc. So in this series, I would be working on this attention is all you need, build the transformers from scratch. So it's categorized as hard by DeepML. It's a deep learning uh, project, and we'll be coding in PyTorch. So yeah, let's get started. So yeah, basically the goal here is that re-implement the original encoder-decoder transformer end-to-end in PyTorch from token vocabularies and sinusoidal positional encodings through multi-head attention, label smoothing, no-M scheduling, and beam search. And by the end, you'll have a working sequence-to-sequence transformer training loop and inference pipeline assembled from first principles. So yeah, so there are like 79 tasks in this project. We'll go through them one by one. And I'm also doing it for the first time. So I'll just be going through the tasks, trying to understand what is required, implementing them, thinking out loud, and just sharing my thought process with you. Uh, yeah, and I also might make a lot of mistakes, but yeah, I'll just be coding live and debugging live and just trying to kind of implement this project and just recording this learning experience to share with everyone. Okay, so let's go to the first task, which is this is only the first task which I had already implemented, but maybe yeah, let's just sometime back, but maybe yeah, just let's reset this so we can kind of yeah start from scratch. So the first task is about tokenization and batching. And what we have to do here is implement this function build token to ID vocab. Okay, to construct a token to ID dictionary from a list of white space tokenized sentences. Okay, the special tokens in the specials variable. So this is the specials variable here. Must receive IDs ranging from 0 till length of special -1. Yeah, makes sense in the order given. Okay. And the remaining unique tokens from the corpus receive IDs starting at length of specials in order of first appearance across the sentences. And tokens that already appear in special should not be re-added. Okay, that makes sense. Let's also go through this section of learn, which they have. Yeah, which will also kind of make us understand like why we are kind of implementing this function, why is it needed. So yeah, why this step exists. So a transformer operates on integer IDs, not strings. So the very first job of the data pipeline is to fix a stable mapping from each known token to a unique ID. So the vocabulary is just a Python dictionary V, which maps a token to an ID where IDs are contiguous integers starting at 0. And special tokens like pad, beginning of sentence, end of sentence are known, are reserved at the front. So their IDs are known constants, reused by masking, loss, and decoding code. Okay. Real tokens then take IDs, length of special plus one, plus two, so on. In the order they are first seen in the corpus. And deterministic ordering matters. Why? Because training, evaluation, and save checkpoints all assume the same mapping. So basically, different parts of the code might kind of call this function. So it's necessary that always the same mapping is maintained. And okay, so this also talks about a common pitfall using set to collect unique tokens. Looks tempting, but gives a non-deterministic order across Python runs, and may also re-add tokens that are already special. Walk the sentences in order and skip any token that is already in the dictionary. Yeah, makes sense because so in Python, the set function is non-deterministic. Like if you call a set of a list, it will give you the unique items in the list. But if you run it again and again, so this is it's not deterministic. Like the order can change. It's different to a set in CV++. Yeah. So let's just quickly go through the examples as well. So let's say, yeah, if we call this function build token to ID vocab and we pass this list, which is the sentences variable, hello world and hello there. So we didn't pass any specials variable. So yeah, we'll assume this is the one. So by the definition of this function, the special tokens in the specials variable should come first. So pad beginning of sentence, COS unknown should have 0, 1, 2, 3 respectively. Yeah, so pad has 0, similarly then 1, 2, 3. And then we'll kind of, after we are done with the special tokens, then we'll go to the sentences and we'll kind of pass them in the order which they are seen. So we'll first come to the first string, it says hello. So we'll see that hello is not already in the dictionary because we don't want to duplicate. So we'll see that hello is not in the dictionary. So we'll assign it 4. Then we'll see world. We'll assign it 5. Then we'll go to hello, but we know that hello is already there in the dictionary, so we can also skip it. And then we go to there and we assign it 6, and we are done. Similarly, the second example, so there are no, and the sentences list is empty, so there are no tokens to process there. But and specials is just pad and unknown this time, so we don't have BOS and EOS. So we'll simply give pad 0 to pad and 1 to unknown, and that will be it. So yeah, let's just try to implement this function. We can kind of initialize an open an empty Python dictionary. We'll just maybe call it token to ID. We'll just create an empty dictionary and we'll maintain our counter like a variable, which we'll get to know like how many words are already processed and like, or we can name it ID. Uh, and just simply let's keep it I. And then first we need to process specials. So we'll just write a simple loop here for token and specials. Uh, so I think the specials by default should not have duplicates. Uh, yeah, let's just assume that for now that at least the special will not have duplicates, so we can simply add them to the dictionary. So token to ID of token will be I, and then we just update I, and we are done parsing the tokens inside specials. After that, we go to tokens inside sentences. So looking at the example, like it's a list of strings. So we'll parse through every string. And so tokens are basically white space separated, white space tokenized sentences. So whenever there's a white space, that means end of the present token and we'll start the new token. So what we'll do is first we'll get the string out of the uh, list. So for string in sentences, and then since we need individual words like white space separated strings as tokens, so what we can do is split this string using white space. We can use the split function. So we just simply create a list tokens equals to string dot split, and by default this uses white space as a separator. And so now we have a list of tokens. It will be hello and world separately. Now we can pass through them. So we just write for token and tokens. Um, what we do here, since we don't since we want to avoid duplicates, what we do is we check if the current token is already there in the dictionary or not. If it is not there, then we kind of update it. Otherwise, we just skip through it. So we'll just say check if token not in token to ID, then token to ID of token equals I, and we update I. And so this check, so dictionaries in Python are implemented as hash maps. So this check is order of one. Uh, it's not order of n or something. Um, so I think, yeah, then we have processed the tokens inside sentences as well. We can simply, do we need to return or do we need to print? Um, I think it's a function, so let's try returning it. Re Yeah, we just return the dictionary we created. Let's try a run on the quick run, the sample cases. Yeah, quick check pass. So if we can go ahead and submit it, let's see like if some more optimization or something is needed. Otherwise, I think if this is fine, then can submit and it should get accepted. Yeah, so this is done. All test cases are passed. So it is, so I've enabled auto git push. So it is also this project, like every time I code and submit something, it just pushes to my GitHub repository where I'm maintaining all the code for this project. So you can refer to that as well if you just directly want to go through the codes and kind of copy and try it on your own. So yeah, so with this, we have done the first step of tokenization and batching, which was implementing this function. We'll go to the second task in the next video. Uh, Hope this was helpful. Yeah, see you in the next video. Thank you. Bye bye.